In countless films, novels, graphic novels, and other works of fiction, humanity's destruction, sometimes even the annihilation of the entire planet, has long captured our imagination. It's no surprise. The question of our ultimate fate has haunted people for thousands of years. Yet beyond the realm of fiction lies a far more unsettling reality. If we set aside speculation and look strictly at the science, we find that some threats from space are very real. From violent solar storms to wandering asteroids and cosmic explosions, the universe holds forces powerful enough to reshape, or even end, life on Earth. Let's take a closer look at the dangers that may one day come from the depths of space. Enjoy watching on the Cosmo Dream channel. It is important to note that the estimates presented here are only assumptions, albeit ones based on serious scientific data. Among such data, for example, is the geological history of the planet. Simply put, we can study ancient craters left after encounters with cosmic bodies. In addition, in the 21st century, large datasets have been collected through astronomical observations. Researchers from different countries and specialized organizations monitor the night sky almost non-stop, compiling a catalog of structures that could potentially threaten the planet. By combining geological data on past catastrophes with the latest astronomical research, it is possible to create an approximate list of the most serious cosmic threats to life on Earth. In 1859, the Sun unleashed an extremely powerful electromagnetic storm on Earth. It caused damage to electrical systems around the world, which at the time consisted mainly of telegraph equipment. Interestingly, when the storm began to subside, the northern lights were observed in regions where such phenomena had never been recorded before. For example, in Miami, USA. This disturbance, now known as the Carrington Event, named after the astronomer who described it in detail, was caused by the most powerful solar flare ever recorded. Such flares, known as coronal mass ejections, occur on the Sun constantly, although not usually on such a scale. However, analysis of tree rings has shown that eruptions up to 1,000 times more powerful than the Carrington Event may have occurred tens of thousands of years ago. At that time, of course, ancient people could not fully assess the consequences due to the absence of electronics. According to some researchers, based on current observations of solar activity, a storm on the scale of the Carrington Event could quite likely occur within this century. Considering the current level of electrification, predicting the consequences is difficult. Optimistic scenarios mention inconveniences in the form of short-term electronic disruptions, but some specialists believe the impact could be far more serious. Every few years, an asteroid roughly the size of a bus enters Earth's atmosphere at speeds of up to 112,000 kilometers per hour. When it explodes, it releases energy equivalent to a medium-sized nuclear explosion. Fortunately, most of these asteroids explode high in the atmosphere or over open oceans. However, luck may eventually run out, and a metal-rich asteroid capable of surviving passage through the atmosphere could head toward a densely populated region on one of the continents. How could humanity counter such a threat? By developing an early warning system that would allow a spacecraft to be launched toward the asteroid to alter its trajectory. The good news is that such an experiment was successfully carried out in 2022. The DART spacecraft, traveling at 22,500 kilometers per hour, collided with the asteroid Dimorphos, the smaller body of the Didymos-Dimorphos binary system, located about 10 million kilometers from Earth. The mission succeeded in changing Dimorphos's orbit, shortening it by 33 minutes. Large, potentially devastating asteroids are considered to be objects over 1 kilometer in diameter. Of course, asteroids can be much larger. In Earth's history, The most famous example is the one that struck the planet 66.5 million years ago. That impact triggered powerful earthquakes, volcanic eruptions, and raised a massive cloud of dust that blocked sunlight for decades, effectively ending the age of the dinosaurs. Today, this event is remembered by the Chicxulub crater, an ancient impact crater about 180 kilometers in diameter and originally 17 to 20 kilometers deep, located on the Yucatan Peninsula. It should be noted, however, that catastrophes of this planetary scale occur far less frequently than collisions with smaller asteroids, which typically cause only localized damage. On average, Earth is expected to collide with a 1-kilometer asteroid roughly once every 500,000 years, and with a truly catastrophic asteroid larger than 10 kilometers about once every 100 to 200 million years. Today, nearly 2,000 asteroids with a non-zero probability of impact are under constant observation. But this term should not be misunderstood. In practice, the real risk of collision in the coming decades is close to zero. Astronomers say there is currently no immediate threat of a star exploding in our galaxy in a way that would endanger Earth. The nearest stars that could potentially explode and pose a danger are simply too far away. However, there is a far more large-scale cosmic threat capable of affecting much greater distances: gamma-ray bursts. A gamma-ray burst is a colossal release of energy in the universe, the most powerful explosions known since the Big Bang. In seconds or minutes, they emit as much energy as the sun produces over billions of years. They occur when massive stars collapse into black holes or when neutron stars merge. In such events, the collapsing star forms a black hole at its core. Matter from the dead star spirals around the newly formed black hole, compressing and heating up. The accompanying physical processes produce powerful jets of gamma radiation. If such gamma rays were to reach Earth, they could almost completely destroy the planet's ozone layer, exposing the surface to extremely intense ultraviolet radiation. This could damage the DNA of countless species, kill ocean plankton, and disrupt entire food chains. Toxic compounds could also begin to fall from the atmosphere in the form of hazardous precipitation. According to popular mechanics, although currently observed gamma-ray bursts originate from stars located far from Earth, they still remain potentially deadly phenomena. A kilonova is an astronomical event that occurs in binary star systems when two neutron stars, or a neutron star and a black hole, merge. Essentially, a kilonova is the result of a collision between two neutron stars. These stars themselves are extremely dense remnants of massive stars that formed after a supernova explosion. Kilonovae are observed much less frequently than supernovae, and neutron stars are relatively small, which makes them harder to detect. In theory, such objects could approach Earth or our solar system relatively unnoticed to a dangerously close distance. In such a scenario, the main dangers would include destruction of the ozone layer, gamma-ray bursts, and radioactive contamination. However, most researchers believe that throughout Earth's history the planet has never actually been struck by radiation from a nearby supernova, let alone a kilonova. At the same time, many astronomers and astrophysicists believe that the end of Earth may ultimately be far more mundane. The reason lies in the evolution of our sun. Over time, the star gradually becomes hotter and will eventually transform into a red giant. This will take about 4 to 5 billion years. When that happens, the sun will expand enough to engulf Mercury and Venus. According to current estimates, Earth will almost certainly share the same fate. In its red giant phase, the sun is expected to remain for about 1 billion years. During this time, solar material will be blown into space, covering the remaining planets with waves of scorching plasma and stripping away the remnants of their atmospheres. As the sun's mass changes, the orbits of the planets will also change. And even if Earth somehow survives the sun's expansion, it would still have a high probability of eventually colliding with another planet. Thank you for watching the video on my channel Cosmotry.